Hey, my name is Marty. We're here in the basement of the McLaurin building. We're going to be doing this initial value problem. She went over this in class when she did the antiderivative day. It's also in the textbook. It's basically a word problem where you're going to use the antiderivative in application. So, if I have a hot air balloon and it's ascending at 12 feet per second, so it's rising at 12 feet per second, and somebody drops a package from that hot air balloon, when it's 80 feet in the air, how long until that package hits the ground? Now keep in mind, the acceleration of gravity near Earth is 32 feet per second. So if something's falling, it's minus 32 feet per second. Now, we're going to say that velocity is v of t and height is s of t. Now, if the hot air balloon is rising the moment I throw the package, at second 0, the package v of 0 equals 12 because the thing is rising at 12 feet per second. So v of velocity at 0 is 12. This is what's called the initial condition. Now, I know that if I know that the acceleration is minus 32. So this is how fast the package is being pulled down towards Earth. If I integrate this, I get minus 32t plus c. Now how do I get this c? Well, I know that v of 0 is 12. So if I do v of 0 equals v of 0 equals negative 32t plus c equals 12, I'm going to solve for c. And, sorry, I should put a 0 here. Now, solving for c, it's pretty obvious that c is going to equal 12. c equals 12. So, now we know that this is our equation for velocity. And what we're going to do now is we want to find out how long until the package hits the ground. So the initial condition for that, we're going to set up another initial condition, and we're going to say s of 0 equals 80. We're going to call the height s. We want to know how long until it hits the ground. So it was dropped when the thing was 80 feet in the air. So height at 0 seconds is 80. Now we need a function s that we're going to find and solve for c using this initial value. And then we're going to have our equation for height. So what we can do is integrate velocity. And by integrating velocity, we're going to have our equation for position, which we've denoted as s. So, integrating this, we get this function here, and we know that s of 0 would have to be 80, so to find out this c, we simply go 80 equals negative 16 times 0 squared plus 12 times 0 plus c. c must be 80. c must be 80. So now, we're almost finished now. We know that that's our function for the position of the package at time t. And we want to know we want to set this to 0 because we want to know how many seconds until the package is at 0 height. So if this denotes the height of the package, we're going to set it to 0 and find out how many seconds until it's at 0 height. Might as well just bring this over here. So, negative 16t squared. Best way to do this, just use the quadratic formula. Don't even bother trying to factor it. Don't reduce it, don't do anything. Just use the quadratic formula, use a calculator, you'll be fine. So this is A, B, C. Quadratic formula, negative B, C, quadratic formula. So you have negative 12 plus or minus 12 squared minus 4 times negative 16 times 80. 2a is negative 32. You're going to get two answers. One's going to be positive, one's going to be negative. Ignore the negative one, obviously. So you got 144 minus 4 times negative 16 times 80 equals 5264. Take the root of that. So you got negative 12 plus 72.5534. I already can see that this is going to give me a negative number. I'm not even going to do this one. I'm just going to do this one down here because I know I'm going to get a positive number. So negative 12 minus 72.5534 equals divided by. And yeah, so 2.6, when t equals 2.64, you know, if you put 2.64 seconds into here, it's going to give you height 0. And that's it.